All right, so the idea is we're looking at KSP and we're looking at all the possible ways that we can do KSP, right? Simplest way to do KSP is that we're saying we got some calcium chloride, all right? That's a 2. Calcium chloride. We're going to throw it into water, all right? And I want to know the concentration of the calcium in the chlorine, okay? So I can say, okay, I know the KSP expression, concentration calcium, concentration chlorine, quantity squared. Okay? If I, can you stop whatever's dripping back there? It's driving me nuts. All right, so I would just plug in this, and then now, here's where you got to be careful with this. Because it is 1 calcium to 2 chlorine, all right? Because it's 1 calcium to 2 chlorine, if we're trying to solve for these, now watch, here's where it becomes interesting. In this case, if we call the calcium X, what's the chlorine? Okay, now, there's the thing. I just talked about 2 girls for every boy, right? If I have 2 girls, every boy, I make this thing, whatever you want to call it, right? If the boys are X, how many girls are there? 2X. Okay? Now, if I make the KSP expression for this, it's going to be KSP is concentration boys, concentration of girls squared, is it not? Okay? So if I'm throwing something where it's a calcium with 2 chlorine, for instance, into water, if I call the calcium X, the chlorine, don't worry about the square, the chlorine is 2X, then we're going to square. Okay? Because if you think about it, if I wrote this expression, calcium chloride goes to calcium plus chlorine, right? I could write that another way. I could say that's the calcium plus the chlorine plus the chlorine. Couldn't I? Okay. So that concentration is squared, but it's also double because for every 1 calcium chloride I throw in, I get 1 calcium, 2 chlorine. Is that okay? All right, that's one instance. Now, what we were just talking about is the idea of precipitating out a chlorine or precipitating something out. All right? And let's say I have calcium in my water and I want to get it out of there. So I'm going to introduce some chlorine. So I have a solution of chlorine. Okay. Now, if I know the KSP, I say, okay, what's the KSP of calcium times chlorine? Quantity squared. Is that legible? No, try again. Calcium times chlorine, the quantity squared. Now, in this case, I threw the calcium and the chlorine in separately so they don't have a 1-to-2 relationship. Okay? In this case, I said I actually should probably write it like this. In this case, I said the triplets here were formed from dissolving that. So for every 1 boy, I had 2 girls. In this case, I just went down, right, and went down to some local school and I said, okay, I need some of your boys. Don't go there. All right? And I went to another school and I said, I need some girls. And said, here, go. And we see how many of these triplets we make. So the amount of calcium and the amount of chlorine that go in are totally independent of each other. So it's not an X and 2X relationship. Do you see the difference? Everybody good? Okay. So in this case, we find this one and plug it in. we find this one and use it as it is, but we still need to square it because that's the KSP expression. See the difference? In that one, they are directly 1 to 2 because we threw those in as one of those and two of those together. So this one is how much will be in solution. This one, we could go the other way. We could say, okay, how much will it precipitate? So if I'm doing a will it precipitate, I'm actually going to use Q and plug in whatever the number is here. So that's the amount here. And this one's this. So we're going to, no, this one's this squared, and we're going to figure out whether it precipitates or not. Do you see the distinction? We good? Okay. Now here's the part you got to be careful with. All right. If you're given something like this, let's say, I don't know, I'll just make one up. Aluminum oxide probably has a KSP. And I say, okay, what is the concentration of aluminum when you're done? Let me give it as an ion. What is the concentration of aluminum when you're done if you just throw this into water? So if I know the KSP, I'm going to go, okay, concentration of aluminum what? Squared, right? Concentration of oxygen what? Cubed? Okay. So what I would do is go, okay, pick a number. Now, if I call, let's do a simpler one first. No, I overcomplicated things. Let's go back to I did calcium chloride. Let's do aluminum chloride. Okay, so if we know aluminum is X, sorry, I backtracked for a reason. Just bear with me. All right. If we know aluminum is X, what's chlorine? If we call aluminum X, what's the chlorine? How much chlorine? If aluminum is X, chlorine is 3X. And then we're going to cube it. So that's going to be 27x to the third times x, or 27x to the fourth. See it? Okay, now this one, this is one of those, and I'm going to say this a lot for the next 2 months. This is one of those where you got to be careful how you define x. If I were doing this problem, the easiest way would be to go, since it's 2 and 3, is to say that this is 2x, the quantity squared, and this is 3x, the quantity cubed. True? Because that's how they're related. But if I were looking for aluminum, how did I define the concentration of aluminum? It's 2x. So if you were to do this problem, you would have to be very careful. If I called that 2x, you get to the end and you find x, you've got nothing. You've got to go ahead and double it to get the concentration of the aluminum. Okay? So be really careful how you define x. Like here, if I said x is the concentration of aluminum, what's the concentration of the chlorine? You got to make sure you triple it. But over here, since they came in separate packages, that's not the relationship. So if they come together and dissolve, it's 1 to 2, 2 to 3, whatever. If they come in their own separate space, it doesn't work out that way. It's just straight up the numbers. Does that work? Okay. Is that helpful? All right, let me stop.